Hello, this is Dr. Vahid Aryadust. Welcome to this presentation. Today I'm going to present how to arrange the output of correlation analysis by groups. Here I have a question that reads: communicative competence is a theory that claims language competency can be broken down into multiple components, such as grammatical ability, language knowledge, and by extension, perceptive and productive skills. By this I mean reading, and by this I mean writing skills. In this scenario, it could be actually listening and speaking as well. Now I'm not going to discuss communicative competence, and I understand those of you who are familiar with communicative competence will not agree with this part of this question, because this theory does not recognize the differentiation between language skills. But anyway, because my purpose in this video is to present how you can arrange the output of correlation analysis by your groups, I think it should be fine. So there are two questions here. Using this core 2016 data set, which is provided, I will show you in a second. Investigate associations between these components which I mentioned and their size. That's actually effect sizes. Yeah, just a little bit of error there. Next, investigate whether the associations remain the same across gender, stream, and nationality. So I'm going to, first of all, I'm going to present the correlation analysis. It's very straightforward. You go to correlate, you go to bivariate, and you choose those variables which I have already chosen for you. Grammar, vocabulary, comprehension, which stands for perceptive skills, and situational writing total score, which stands for basically the productive skills. So for options, you can choose mean and standard deviations. Actually, that's fine. I mean, I'm going to keep that, and for the rest, you just leave them as is and click OK. There you are. You get the correlation between all those variables. So grammar score and vocabulary score have a high correlation of medium correlation of 0.511. Again, medium correlation is observed here. Comprehension score, and so on and so forth. We have seen how I run correlation analysis in another video. So today the major focus is on how to split this based on gender and based on nationality, etc. So in order to do that, you have to do a split file operation. You have to go to data, go all the way down to split file, then click on split file, and this window pops up. We have a few options here. We want to organize output by groups, so I'm going to choose this. The first variable that I would like to organize my output by is gender, and that's here. Then secondary school stream, which in other videos I have shown is 3, and then citizenship as well. So you can also click on citizenship. So it could be one variable in your analysis, or it could be more than one variable. It doesn't really matter as long as you know what variable to choose to organize your output by. It should be fine. So that's it. I'm not going to do anything else. Just click OK. Now SPSS generates this little piece of syntax to inform you that it's going to sort cases by gender, stream, and city. City is citizenship or nationality, actually. So let's go back to analyze, correlate, and bivariate. Nothing really changes. You're going to do the same Pearson correlation analysis for this data set, and you just click OK. Now, however, the output, as you see, is quite different. This is the result of the previous analysis. This is the result of the current analysis. So you can see that what is your gender, female, then secondary school, stream, express, and what is your citizenship, permanent resident, have been combined together, and the correlation of those subgroups, of this subgroup, has been provided. So for the subgroup female, uh, whose stream is express and whose citizenship is permanent resident, these are the correlations. The correlations between, for example, vocabulary. Let's compare this. So for this little subgroup here, where the n is 56, there are only 56 variables, 56 people in this subgroup. We can see that there are the correlation has dropped down to 0.387. Let me just go back to the original correlation analysis just to refresh your memory. Where is that? Where is it? Oh, this is all the way down. Okay, so this is the first correlation statistic. As you see, it was 0.387, and now the correlation at the sample level is 0.511, which is larger, and I'm not surprised because the sample size is much larger, is 1859. So in the same way, you can compare the rest of the groups together. Now, if that's too much to make sense of, you can actually move back two other variables and only focus on gender. So estimate correlations among those variables across the two gender groups. I think this will be easier to make sense of. So I'm going to generate correlations for females separately from correlations correlations for males. So I'm going to click OK, and this syntax is generated, and that's it. So that means that the files are now split into based on the genders. Then go all the way down to correlate, bivariate, the same data, the same setup, and just click OK. So we have some missing data, or just ignore that. Really. For males, the correlation is 0.488. The correlation between grammar and vocabulary, which was, as you saw earlier in the whole sample, it was 0.511. So it has dropped a little bit here, probably because of the sample size is one of the reasons. And in the same way, you can compare the correlation between others. Here, from what I recall, the grammar score and comprehension score have a higher correlation here. I think these correlations have not changed that much, or I don't recall that there is a significant difference between this and the actual data set. For females, you see the correlation between grammar scores and vocabulary scores is 0.527, which is significant at a very small p-value level. Now, let's compare this, females versus males, and as you see is 0.488. So this is kind of larger than the previous one, but here the correlation has, I think, let me see what has happened for males. It is 0.53, 0.503, and this is 0.459, which is somehow smaller than the previous one. And finally, for the situational writing total score and the grammar score is 0.387. Here is similar, quite similar, 0.369, but you see the differences. They're not exactly the same. In this way, you can find the correlations across groups. So you can go back again to the split files and you can reset everything. And this time around, again, choose organize output by groups. This time around you can move streams to this groups based on kind of dialog box, and click OK. Now your data, your output is going to be sorted based on the streams. So let's go back to correlations and run the analysis again. And let's look at the correlations of those components of communicative competence across the streams. For normal technical, interestingly, there is no significant correlation because the p-value is 0.057, which is larger than 0.05. So there's no correlation between grammar scores and vocabulary scores for the normal technical. If you recall from previous videos, the normal technical group has the lowest mean score across the three groups. It's interesting that we didn't find any statistical significance here. And at the same time, the grammar score and comprehension score have a much lower correlation if you compare it with the entire sample size. Now let's look at the normal academic. As you see, the correlation is significant, and here the correlation between comprehension and grammar score is significant and also slightly higher than this one. So normal academic um, seems to have a higher correlation, seems to show that there are more correlations or more significant correlations between those components that we've been testing. For express, it's a lot higher. For the vocabulary score, 0.3, and grammar score, we see the correlation of 0.367, which is significant, and this one, this correlation coefficient also goes up, and this one, situational writing and grammar score, is 0.3235, which is larger than this for normal academic and larger than smaller than that for normal technical. It's very interesting. You see the correlation coefficients change across groups. Therefore, I think it would be a good idea for us to compare the correlations among the components that we have using data and split file menu. Therefore, I investigated the association in this way. So by the way, association typically means correlation. So if you are interested in investigating associations among variables, it would be pertinent to use correlation analysis. Thank you very much for your attention. I hope this video was helpful. If you liked it, give it a like and subscribe to the channel. Have a good day.